A new perspective into the frataxin function was recently suggested by our group. We found that frataxin acts as a regulator of iron-sulfur cluster formation and an iron sensor. Using the bacterial model system, we assumed that, if frataxins were iron chaperones, its presence should neither perturb the enzymatic reaction rates, nor, and in the most favorable case, enhance reaction speed. Much to our surprise, we observed that the presence of frataxin affects negatively the iron-sulfur reaction kinetics, thus producing a classical inhibitory effect. We have proposed that the bacterial frataxin may function as an iron-sensing negative regulator, which acts as the gatekeeper of iron-sulfur cluster formation. This hypothesis would explain the following experimental observations. 1. Why frataxin is an essential protein. The ferritin-like hypothesis cannot explain it because in mitochondria there is already a ferritin. The low iron affinity and specificity is also not easily in agreement with the chaperone hypothesis. 2. Why frataxin has low iron affinities. This is required for a protein that is an iron sensor. 3. The long-term accumulation of Friedreich's ataxia symptoms. As a sensor, even small frataxin concentrations would be sufficient for cell viability, but frataxin deficiency would eventually trigger the long-term effects. 4. Why frataxin is associated with oxidative stress, and with the observation that time-dependent intramitochondrial iron accumulation in frataxin-deficient organisms is observed after onset of the pathology, and after inactivation of the iron-sulfur-dependent enzymes. As a regulator which tunes the quantity of iron-sulfur cluster formed to the concentration of the apoacceptors, any reduction or depletion of the frataxin level will upset this equilibrium, and lead to an imbalance of the iron-sulfur clusters produced as respect to the apoacceptors.